Thank you, Dr. Sabharwal and Dr. Knightley, for extending the invite. I'm very pleased to be here today. I wanted to give you some of the perspectives of a service provider in the industry and talk about how innovation plays a role in what we do. Actually, if you think about it, this is a network that we rely on constantly. Every second you expect it to work, 24/7. Not only that, you want it to work everywhere, at home, on the road, in this classroom, everywhere, right? So there are a lot of demands that are put on service providers, and I wanted to get you have a feel for that. And in fact, we also work under a lot of constraints. We have finite spectrum, we have finite resources, we have finite capital to invest in the network, we have to watch our operating expenses, we have resource constraints. But the one thing that helps us set this apart or overcome these constraints is innovation. It is innovation that helps us differentiate. It's innovation that helps us enhance the network performance and helps us meet or even exceed the customer expectations. Speaking of expectations, we have been seeing a lot of demand data growth, over decades. We've come from 2G, 3G, 4G, you're all familiar with it. That's not stopping with 5G. We are continuing to expect more and more. And I'm just showing capacity here, but really it's much more than capacity. As we think about what we are looking at in the future, we are looking at higher speeds than before, higher capacity at the A node B sectors, but we're also talking about higher density. There's billions of devices. We heard they talk about sensors today. They're going to be everywhere. How do you scale our network to be able to support that and support that everywhere? That's a big question. It also has to be low cost, has to be low power. We are talking about ultra-reliable, low-latency services, so latency becomes more critical as we look at migrating from 4G to 5G and going to 6G. There's talk about 6G already. And then it's, not just surgery or something, but banking transactions, everything. I mean, there's virtually unlimited applications that people are dreaming up for 5G. We have to support all of this with the finite resources that we have. So how are we doing that? I wanted to provide you a glimpse into some of the key solutions that we at Sprint are looking at. There's 4 of these techniques I've shown on the chart here. I'll be talking about each in a little bit, but mainly we will be leveraging all the spectrum we have. Spectrum is the most prized asset for operators. That is our key to doing everything that we want. And then beyond that, how do we use technology? So I'll be talking about small cells. Today we have a network that's macro base stations. We also have some small cells, but we are using small cells as an underlay to the macro networks. How we use it is key to our realizing capacity gains, coverage gains, density gains, and all that. And so I'll talk about something we call the magic box, which is developed for indoor use, can be used outdoors as well. We'll talk about outdoor small cells. And last but not least, I'll talk about Massive MIMO and how we're using it to go from our today's 4G LTE network into 5G. So on to spectrum. So we have access to 3 bands. The first one is the band 41 or 2.5 gigahertz. We are fortunate to have a lot of it. We have about 160 megahertz in the top 100 markets. We also have the 1.9 PCS band and also the 800 megahertz band. Both of these, actually all 3 of these are fantastic. We get the balance of good capacity with coverage in the mid bands, and then we rely on the low bands to extend indoors like where we are today, make all our sensors work, make our IT devices work. The key to actually giving the performance I talked about everywhere with good capacity and coverage is using all of these in a combination, using appropriate load balancing, using traffic management mechanisms to switch the user from one to the other as needed, and hopefully we would do it seamlessly so you're all comfortable with the services you get. The other thing that we are relying on is small cells. Small cells are really elegant. I mean, these days you can hardly see them on the light poles. But there are a lot of challenges with small cells. The thing with small cells is if you want to do that in a big way, then you're dealing with cities, with right-of-ways, with all kinds of regulations. Those are not streamlined. Even in 4G, when we started to deploy thousands of small cells, that was a long process. We had lots of project managers talking to city officials, trying to see where we could deploy them. And then when you design a network from an RF perspective, the ideal locations you would come up with to place a small cell, you either don't have access there, or you don't have power there, or you don't have backhaul there. So that's a big problem. So backhaul, siting, zoning, real estate, these are all the key problems that we're already facing. Now, as we go to 5G, and I mean 5G with millimeter wave, sub-6, everything, we are looking at deploying, millions of small cells maybe. And how do we solve all that if you don't make streamlining possible? So there's plenty of challenges with just a simple concept of small cells. So some of the ways we are looking at solving that problem. Here's one of them. We call that the magic box. This has been deployed, hundreds of thousands of these. These were first designed to be indoors. All it is a small cell, but it is using wireless backhaul. So we ship this to the customer who's having a problem, and all they have to do is plug it in. That's it. The box then auto-negotiates which node B it should connect to. So there's wireless backhaul that's in band, in the same band 41 we're talking about. And there are two sectors, one pointing indoors, so the customer gets good coverage inside the house, and one pointing outdoors to the window, so the neighbors as well as people walking outside get good coverage. So we sort of accomplish two goals in one. We are enhancing the indoor coverage for a customer. We're also enhancing the coverage outdoors, not only through our macro sites, but also to these small cells, which the customers are putting indoors already. So we think that's a good, innovative solution that's very practical and providing us good benefits. The other one that we are doing is called strand mount. So what is that? That's also a compact small cell, but we're leveraging partnerships with cable providers to do this. So we hang these on the aerial cables. They're really small. They're not very powerful in terms of the radiated power, maybe 250 milliwatts or so, but we can place them in a lot of places. So we are attacking the problem with scale and densification. And the beauty here is you already have power. You already have backhaul. And you avoid all the zoning constraints and the regulations that we talked about. So this is one example of how we as operators can come together with our partners to solve some of the big problems. Now to Massive MIMO. Now I know this is the home of Argus, and there's a lot of experts here in Massive MIMO. I feel like I'm preaching to the choir, so I'll stay high level. But really, the fact that we are able to send multiple independent data streams, and lots of these streams, has a direct impact on the first thing I talked about, spectrum. I can use my same spectrum to accomplish what I would do if I had 4 times or 10 times as much spectrum, depending on how many layers I can support in my Massive MIMO sites. So as the depiction shows, before that, my MCS levels, my capacities were really low. With Massive MIMO, everything gets boosted up. It's not just the peak and average data rates. I get fantastic coverage and capacity at the cell edge as well. The other aspect here is I actually literally gain another dimension here, because now it's not just horizontal. I can do this in the vertical dimension. So think of high-rise buildings in New York City and other places. We struggled in the past before this by putting up small cells on top of a macro towers to provide coverage. We don't have to do that anymore. This single radio will do everything. So we are very excited, and we're actually rolling this out commercially, and we're looking to see how best we can leverage this. So I'll talk a bit about how we are going from 4G to 5G. We've been doing trials and proof of concepts since 2016. We did demonstrations at 15 gigahertz and 73 gigahertz outdoors in stadiums. It was really hot all day. The equipment didn't overheat. We found ways to integrate live virtual reality. So customers or people who were visiting the stadiums would just walk by, put on the VR glasses, and experience the benefits of 5G from a latency and throughput perspective. And this was, a couple of years ago. We then also looked at Gigabit LTE speeds, and I'm talking about 4G now again. In 4G, it's catching up in terms of capacity. You got 3GPP specifications that allow you to do multiple good things. In fact, Massive MIMO is part of 4G. It's a key foundation and building block to 5G, but it exists today in 4G. So Couple, not Massive MIMO, but just say 88R, where you may have 2 to 4 layers of MIMO. Couple that with carrier aggregation, 20 megahertz of channels each, and high MCS, we were able to get close to gigabit rates, and that was 2017. Then we have started doing some testing with Massive MIMO. We went to Korea. Samsung is one of our OEM partners on the radio network side, so we went to Seoul and we tested there. This was a 32T, 32R radio. We found fantastic performance gains there. We saw about 3x on the downlink. We saw coverage gains as well. Subsequent to that, we also tested with Ericsson in Seattle. That was September 2017. And this was a 64T, 64R radio. We found about 4x gains on the downlink. We found gains on the uplink as well as coverage expansion. We've run simulations and shown that with demonstrations at Mobile World Congress in Barcelona. What we found there with simulations was if you have 60 megahertz of spectrum and you look at the peak scenarios, you can get about 3 gigabits per second from a sector perspective with just 60 megahertz. That's about a gig for every 20 megahertz. Now, if you imagine that on your cell site and you've got 3 sectors, this quickly adds up. So we also wanted to see how well Massive MIMO would work because we have concerns. Would it really work in a setting like these when people are really close to each other? Would it work when people are mobile? How would it work indoors where you have multipath going on? And so we tested, we actually had a demonstration at Mobile World Congress in LA last September. And we took Ericsson's radio and we were able to show by placing about 16 different devices just around the booth, we were able to maintain connectivity. We were able to get 16 layers to each of the devices. Using a single 20 megahertz channel, I was able to get about 730, 740 megabits per second. And this was with 64 QAM only. So if we had 256 QAM enabled, which we do now, we would have seen 1/3 more. So that's about 1 gig in 20 megahertz, which is what we were simulating before. Now, this is peak conditions, this is the ideal thing, but it gives you a target as to what you're capable of. It also gives you insight into what happens if you go from a mobile network to perhaps a fixed network, or you make a mix of it. If all of your users are fixed, you can hope for better connections, better MCS, less channel variations, and you can approach peak capacities. So this gives you a good feel for what we can get with Massive MIMO with just 20 megahertz. And this is sub-6, I have to point out. We were doing this at band 41. This is not millimeter wave, and that's actually better in many ways because now I have this massive capacity with fantastic coverage. I'm not limited to 700 feet or 1,000 feet from the site. So what we are doing there is exactly that. We're leveraging our 2.45 gigahertz. We have Massive MIMO radios, and I'm showing you a radio that's opened up. It is a 64T, 64R radio. There's 128 elements, 2 cross bolts on each of those 64 branches or the transceivers that you see there in the radio. And then if you see how it compares, we place this right next to our 88R radios. Now that's doing LTE in the same band 41, TDD, 8 branches. This was our deployed network before we introduced Massive MIMO. And the radio is separate from the antenna. So you see the antenna, that's a tall unit over there. And the radio together are actually more voluminous than the Massive MIMO. So it's a Massive MIMO that's massive, not the radio itself. The radio actually is about the same size or even smaller depending on the implementation. So that actually helps a lot in terms of wind loading and weight on the towers and things like that. So it's fantastic also because we are able to leverage LTE as well as 5G. I'll speak a bit more about how we do it, but at Super Bowl, we deployed 32 sites around the stadium with Massive MIMO, and the performance was fantastic. We had about 150% more traffic than we did last year. Clearly, there's a need for these things. We are already deploying this commercially at thousands of sites, and we are on way to proceed to do that even more as we look at 5G. So how are we going about it? So on the left, you see what we have is LTE Advanced. We have our 88R band 41 radios that I talked about. we are replacing or augmenting that with these Massive MIMO radios. So at the same site, we are basically adding a channel card that supports the Massive MIMO radios, and we change out the radios on the top of the tower. Now, these radios are using what we call a split mode, and that is a real innovation in this area. The fact is, we are not bringing in new radios to do 5G. We're using the exact same radio we're doing 4G Massive MIMO with today, but we are splitting it. We're using half the transceivers, 32T, 32R, for 4G to continue with our legacy service, and we're using the other half to turn on 5G. It's just a simple software upgrade for us. So that is what we will be looking to do as we deploy 4G today, take advantage of that very cost effectively to turn on 5G everywhere. And then in future, should we desire to, we can take the LTE traffic off of that particular band and use the entire band 41 for 5G and leverage Massive MIMO completely for 5G on those sites. So this helps us, the split mode strategy helps us do what's called ENDC in 3GPP. That's basically dual connectivity. So my phone can be connected simultaneously to 4G and 5G. And I want to point out that this is very different from what millimeter wave-based 5G is, because there you're limited to much smaller cell radii or cell areas, and you have to switch from one to the other as you transition. Here, with our deployment, we have 5G everywhere we have 4G today. So you can actually get both of the signals together. And talking about peak speeds, if you have 60 megahertz on one and 60 megahertz on the other, you can leverage both of them together. And doing so allows us to give you more than gigabit levels at the device end. So we are very excited to see that happen and see what users are going to use all these speeds for. So just to give you a little pictorial depiction of how we are expecting our coverage to be. So if you have this whole area lit up already with LTE, we're using half of that Massive MIMO radio to do LTE service, continue with that. And then we're going to turn on the other half of it to basically add 5G to everywhere that you had LTE. And this is fundamental in that you're not having a coverage difference. In fact, it's the same coverage area, and your capacities are probably a little better because 5G does bring in a lot of efficiencies. But if you compare with Massive MIMO, it's the same underlying technology with the additional efficiencies of 5G, so you're getting the benefits of ENDC that I talked about before. All right, so I also wanted to point out a trial that we did. This was with a third-party signals research group. This is led by Mike Thielander. We invited him to Plano, and he did his testing there for us. So we let him go with some devices, and he drove around and did his own independent testing. And he observed similar results to what I was saying before that we had done on our own trials. He saw about 3.4x throughputs on the downlink compared to 8T8R. But he also saw, and we had seen that too, about a factor of 8.9 throughput increase on the uplink. Now that is very significant because in a TDD network, based on what the asymmetry of data rates are today, we are seeing ratios that have increased from 6 to 1, 8 to 1, they're going to 10 to 1 today on our network. So we're using frame configuration 2 on our TDD network today, where we have roughly 20 to 25% on the uplink. And so while we are all focused on the downlink in terms of peak speeds, and you see the marketing claims that are being made, it's really the uplink that we care about quite a lot in certain situations. So when you're at a stadium, you want to send something, or you want to stream something, upload something, that's the uplink that you're relying on. This technology, Massive MIMO, is not just helping on the downlink, but it's actually helping us on the uplink as well, because now you're reducing interference, you got better beams, and you have more of these beams that help the uplink customers. So that was a significant finding, or actually it was a good validation of what we were seeing internally in our own trials to have that being done by an external third party. The other thing that he pointed out also was that, look, if you have 100 megahertz spectrum and you're getting 3x gains conservatively, that's the same as having 300 megahertz of spectrum. So the advantages of multi-user MIMO that you have at sub-6, and you may not have all that in millimeter wave, really becomes apparent when you think about how our breadth of spectrum, 160 megahertz in the top markets, translates to equivalent spectrum that is a factor of 3 to 4 or even more. So that is why we're all very excited about Massive MIMO. So we are using that to bring 5G. You've probably seen these sort of claims before. It's not just capacity. We are looking to get low latency numbers. We're looking to support huge increases in traffic density. We're looking to have massive amounts of devices as well. And all that is to support a multiplicity of use cases and verticals. We heard this morning about sensors being everywhere. We need to support these sensors indoors, outdoors, mobile. Now, it's not just the sensors and it's not just your smartphones, but actually the thoughts around 5G are leading to a lot of use cases, a lot of new business opportunities, a lot of applications are coming up. We're looking at smart factories, we're looking at autonomous cars. We talked about healthcare already. There's smarter agriculture, how we can make conserve the use of energies and utilities, make cost-effective use of the same, use the same for public safety, sustainable infrastructure for the cities, and digital logistics and retail. And these are only a few of the use cases that people are talking about for 5G. The fact that you can hit not just capacity but also latency and also security and reliability really opens up the breadth of opportunities that we have as we go from 4G to 5G and we look forward to 6G. Now 5G, we've actually turned it on. It's up. It's a test network. We are optimizing it, but it's live right now in Chicago with Samsung. We've already done mobile testing with it, so happy to say things are looking good there. We have plans to actually put commercial 5G this half of the year. So by the first half of this year, we'll be having 9 markets come up. And these are not just hotspots. These are really tens to hundreds of square miles covering large areas of downtown metropolitan areas in all these markets. And Houston's on the list too. All right. So to do all this, it does take a village. We have been working with academia, such as yourself, industry bodies, IEEE and 3GPP. We've been working with Power, we've been working with 3GPP, we've been working with DARPA, working with NSF, GSMA, GTI, global ecosystem partners, our own RAN and chipset partners, and also with government agencies. And really, frankly, we need all of them together to help us, not just with the technology aspects, but with the deployment aspects. We need the help of the government to streamline regulations to allow us densification for the small cells that we talked about. We need to make better use of spectrum. We need more spectrum. We need good spectrum to be reallocated. We need a mix of high band, low band, and mid band spectrum to get to the ideal way that operators can actually do this for us. So just a pictorial to see how we might evolve our architectures. I talked about our macros base stations being where we are today. So that's your LTE Advanced. And then when we layer on Massive MIMO, you got that more yellow circle in the middle. That is where we put Massive MIMO in. And as we see the need for more capacity, we would then turn on 5G at our macro sites. So that'll give us additional capacity. And then if we still need more, we can do densification, like I talked about, using the same band 41. Or we can even rely on millimeter wave small cells in hotspots and dense urban areas where we really need that capacity and where that investment is worth it, on top of our existing mid-band coverage that we have, both in LTE and 5G. So a lot of opportunities for us to think about as we go back to the most precious asset we talked about, which is spectrum. Now, we're exploring a lot of ideas in a lot of areas, and I just wanted to throw this slide in front of you. When I was graduating, it was like, hey, I want to get out there and do something meaningful. I didn't know exactly what. But as I look at this now, saying, hey, I work for a service provider has a lot of meaning. We are doing research in each of these areas. I've touched on Massive MIMO a little bit. We heard a lot about full duplex. That's very exciting to us. In fact, one of the fantastic applications of full duplex in our network is on the TDD relay systems on the small cells, because now I can have backhaul and access using the same spectrum, which solves a lot of problems as we look at using a finite amount of spectrum to go from 4G and 5G. And oh, by the way, we can't turn off 4G now. It's got to stay for another 10 years or more. So full duplex has a big role in what we're looking to do. HetNets, of course, small cells, macro, terrestrial, non-terrestrial, all that, the combination of that is required. We are also looking at changing architectures from what we have a distributed architecture today, where you have the radios and the baseband processors at the same site. We're looking at centralizing it and moving it to the cloud so we can do all kinds of fancy stuff like network slicing and offer differentiated services to all of us. And we're looking at leveraging the same networks for fixed wireless access as well. I won't go through each of these, but there are a lot of areas I'd love to have discussions with any of you that are interested offline as well as to what we are doing and how you might have an interest that actually leads to something meaningful in each of these areas. I'll touch on a few other things. Wireless backhaul is key to everything I talked about. It's not just access. Wherever we put small cells, we have to find a way to backhaul it. Paying for fiber everywhere can be really cost prohibitive. It can be a showstopper, so we have to figure out how we can use wireless backhaul. And we can use Massive MIMO that we talked about. We can leverage full duplex. We can do all kinds of things. In fact, we love bringing different areas together to form new products. We talked about full duplex separately. We talked about Massive MIMO separately. Why don't we have the two together? So if I could have a Massive MIMO radio that has full duplex in each of the transceivers, that's fantastic. I've already got spectrum gains with the Massive MIMO layers. Now I'll have even more with full duplex. How about I take that a step further and I say, I want to do that in a small cell. I want a 16T, 16R small cell that's a small form factor I can deploy in the light poles. I want 360-degree coverage with it. I want to be able to have plug-and-play wireless backhaul, SON included in there, throw in AI as well. All that makes sense as we think about combining these different things together. And to go to another example, we are talking about backhaul rates in several gigabits per second. We've looked at millimeter wave. We've heard about E-band. These already exist in point-to-point links that give you, that gave us 2 gigabits or so a decade ago. Now they're giving us 10 gigs and more. Can we not have a point-to-multipoint radio at a tower that supports multiple of these links, just like Massive MIMO does? And I can use that for backhaul. And oh, by the way, I would love to have full duplex on that too. There's so many different ideas here. I'm excited to share these with you and see how we can work together to maybe take some of these ideas to fruition. Just touching a little bit more on some other examples, it's not just about terrestrial networks. We've been exploring HAPS as well. We've done some trials with aerostats. A lot of work going on in this area already. This is where the future is going to be. We're going to rely more and more on these because we want all these applications and the connectivity everywhere we are, even in remote areas that we travel to. So these become an integral part of a service provider's network as we look to the future. And then it's also SON. As the networks become more complex, as we look at macros and small cells, terrestrial and satellites and HAPS and whatnots, how do you manage all that together, keep everything running smoothly? When something goes down, you know instantly how it can be fixed. You don't have to do it. SON helps you do that. How do we go from this basic state where we are today, where we are even having trouble with ANR in sometimes, but to go beyond that, to have high visibility into problems, capability to fix them dynamically, handle multiple heterogeneous networks, and leave room open for future enhancements. There are a lot of problems to be solved in the SON area as well. I mean, if you're just focusing on SON, that's a great future. Another area is AI and ML. Can't leave this talk without mentioning that a little bit. It's everywhere. We, of course, see uses for that in back office applications. We can use them in network planning. We can use that in network optimization. We can even use that in product design. We can use that in DPD design, for example, or we can use that to automatically throw in security measures to known threats. That's becoming a big issue of focus these days. So everything now seems to boil together into use cases for us that we can really leverage. So hopefully I've given you a good perspective into what we are doing as service providers and how we are looking at multiple research areas and how we could use your help going forward in each of these. So with that, thank you.
We have time for one question. Running late a little bit. Question? Just speak loud.
Oh, there it is.
Thanks very much for the talk. Great to see the technologies getting taken from the lab all the way to the providers. My question for you, there's so many cool stuff coming in the future and a great roadmap ahead. Are there any big roadblocks in that roadmap or things that keep you up at night of if we don't solve this problem, we're just not going to get to the vision that you showed?
Yes, definitely. There's plenty of those, but some of the key ones, even with Massive MIMO, are scalability. So we have done trials and tests, with certain amount of spectrum. We want to do this on all of our spectrum. So scaling an idea that works to the scale that's required is not always easy. We stumble there, so we have to look at how the vendor community can do this. Since we are trying to do 4G and 5G together, we have yet to see how we can dynamically take the best advantage of our spectrum, so dynamic sharing on a scalable fashion. And then how do we really marry these other things I talked about that I want to do? I want to throw in full duplex, I want to throw in AI, I want to throw in so on. Doing all that in a timely basis and yet supporting all the applications we talked about while we make these upgrades is really what keeps us at night. I'll add in another perspective to answer. The innovation we talked about, a lot of drivers we mentioned, right? Capacity, coverage, latency. The biggest thing there that makes it useful for us is simplicity. An idea has to be simple to implement, simple to design, simple to deploy, and simple to operate. So that is key to the innovation. So that's what keeps us up at night. Thank you so much for the opportunity.